Let's start with our laws of motion today. So our first question over here says, in case if you have not watched the previous one, I have made a playlist and uploaded, so you can watch the previous part or previous videos. Let's start with our question number 1. It says a bullet from a gun is fired on a rectangular wooden block with velocity u. Okay, fine. So let's say this is a bullet and it is fired in this direction with the velocity u. Okay, fine. U is the initial velocity. When the bullet travels 24 centimeter through the block along its length horizontally, velocity of the bullet becomes u by 3. Great. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. Good. So question says here, while I'll explain this part, the total length of the block you have to find. So let's understand, let's break the problem. The problem says that you have a wooden block like this. Okay, this is a wooden block, or let me make it little big so that we can understand it much better. So this is a wooden block and a bullet with initial velocity u is fired on the block, right? So after hitting, it is traveling how much? It is traveling 24 centimeter, where its velocity reduces to u by 3, correct? So up till 24 centimeter, its velocity reduces to u by 3, and further it moves to the back end, right, at the back end of this wooden block, where it finally stops, correct? So final velocity here also is 0. We have to first calculate this length. Once you calculate this length, add it to 24 centimeter to get the total length of the block, right? So here this problem we will solve it using equations of motion, because the constant acceleration or retardation it is going through, because the force imparted by this bullet will be constant, right? So initial velocity in the first half of the journey. So let me use the equation v square minus u square equals to 2as, right? While going 24 centimeter, okay? What is the final velocity? At the end of 24 centimeter, the final velocity is u by 3, correct? So let's say square minus initial velocity is u square, that will be equals to 2a into distance is how much? Distance is 24. I hope this is clear. Now let's simplify it. This becomes here u square by 9 minus u square will be equals to 48a. I hope this is clear. So this will give you minus 8 by 9 u square is equals to 48a. Let's take this 48 on the left hand side, and this will become minus 8 by 9 into 48 u square will be equals to our a. Let's cancel out this 8 with 48 and we will get here 6, right? So once you get 6, it will be minus u square by 54. That will be our acceleration, the constant acceleration, or you can say retardation, because it's a negative acceleration with which the bullet is moving ahead, right? Now if this is the constant acceleration with which the bullet is heading in the forward direction, let's focus on this journey, this part. So in this journey, what happens basically, at the end we have u by 3, so that will be the initial velocity, right? So here again I am using the same equation, v square minus u square equal to 2as. Here initial velocity will be u by 3, because at the end of 24 centimeter, the final velocity of at the end of 24 centimeter will be the initial velocity for the next part of the journey. So this will be minus u square. What's our initial velocity? Oh great, here I have made a small mistake. V is 0. The final velocity at the end of the block will be 0, because it is getting stopped as per the problem. And minus u square. U is what? U by 3 whole square, correct? And that is equals to 2a. What we calculated a as? Minus u square upon 54. So let's put here minus u square upon 54, okay, into distance s. Let me repeat again in case if you are confused. See, the block is in the block, the bullet is traveling with the velocity u, it is entering, right? At the end of 24 centimeter, the velocity becomes u by 3. So the remaining half of the journey, the initial velocity for that will be u by 3. And at the end of the block, the velocity becomes 0, right? Acceleration remains constant because the constant force is imparted. So this will be minus u square by 9, and that will be equals to minus 2u square by 54 into distance s, correct? Let's cancel out u square on both the sides. So u square gets cancelled with u square, and let's cross multiply. Minus gets cancelled with minus, and we left with 54 whole divided by 9 into 2. That will be equals to s. Now let's cancel out this 9 with 54, 9 6 and 2 3. So distance travelled in the remaining half of the journey is 3 centimeter. Let's go back to our problem and understand the concept. This part is 3 centimeter and the first half of the journey is 24 centimeter. So the total length of the block. So let me write here, length of the block will be how much? 24 plus 3, which is 27 centimeter is the length of the block. Let's see if there is any option. Yes, option D is the correct answer. I hope you are clear with it. Otherwise, just rewatch this part so that you will understand it. Great. Let's move to our next question. Our next question says, a truck is stationary and has a bob suspended by the light string in the frame attached to the truck. The truck suddenly moves to the right with an acceleration A. The pendulum will tilt in which direction? Interesting problem. So let's assume that this is the truck. Okay, let me make it little big because I'll have to draw the FBD also, free body diagram also. And this is a string and this is a bob attached to it. The truck is moving in the forward direction. In which direction the bob will experience a force? Sir, of course, backward direction. Pseudo force if you have done, right? So let's assume at any instant the bob is like this. At any instant the bob is like this, and this is the vertical initial position. Because of the inertia, the bob will go on the left hand side, correct? Let's see what are the forces acting on it. So here downward in direction, it's the weight of the bob mg, and here it is tension T, and pseudo force acting here ma, correct? A is the forward acceleration of the truck, so pseudo force will be acting on the left hand side. Let's draw the FBD here properly. So here we have tension T, mg downward, and ma in this direction. Let's go back to the problem. What does it says? The truck suddenly starts, okay, and it moves to the right with an acceleration A. The pendulum will tilt in. Okay, now if you look at the options, they are saying with the angle we have to find, right? So let us assume this angle theta, then this will be angle theta over here, right? Correct? So that is theta, so that will be alternate angle and you can say it theta. Now let's split our tension force. It will be T cos theta upward in direction, right? And T sin theta on the right hand side. We can split it. Now T cos theta is equalized by the weight, which is mg, and T sin theta, that is equalized by the pseudo force ma. This is equation 1 and this is our equation 2. Let's divide equation 2 with equation 1. That will give us sin theta whole divided by cos theta, that will be equals to ma upon mg. Let's cancel out because T already cancelled, right? Tension T cancelled on both the equations when you divide it. M also get cancelled and we left with tan theta, that will be equals to how much? A upon g. Clear it is? And this implies theta is nothing but tan inverse A by g. Oh, we have two options with this, option B and option D. Let's read them. B says to the left, and the angle of inclination of pendulum with the vertical is tan inverse A by g. To the left, option D, and angle of inclination of the pendulum with the vertical is tan inverse g by A. So look at this, this is tan inverse A by g, that's option B is the correct answer. I hope this is clear. Let's move to our next problem. Beautiful problem, let's focus on this. The problem says a balloon with mass m is descending down. So let's imagine that this is our balloon and it is descending down. Okay, great. With an acceleration A. So acceleration over here is A, and A is less than g. Of course, it will be less than g, right? How much mass should be removed from it so that it starts moving up with an acceleration A? Okay, let's understand this, break this problem. So if this is our balloon and it is descending down, it is descending down because of what? Because of the weight, right? If the weight is very less, okay, compared to the gravity, okay, if weight is downward, okay, and buoyant force is acting upward, the balloon goes up because of buoyant force, right? We know that. Let's call it as B. B is the buoyant force. If the weight is greater than the buoyant force, the balloon will descend down. If the buoyant force is much greater than the weight, then of course it will lift up, right? So let me make a FBD here. Let's say the mass of the balloon is m and g. Oh, it's given the balloon is having a mass m only. So m and g, weight is acting downward. Upward direction is buoyant force, right? Buoyant force. So if the buoyant force, if the weight, in the first case, weight is larger than the buoyant force, so the weight is larger, so mg minus b must be equals to mass times acceleration of this balloon, equation 1, right? Now the problem says you have to remove a little bit of mass from the balloon, right? If you remove the mass, the balloon will feel lighter, which means buoyant force becomes more than the weight of the balloon, right? So let's draw the FBD once again. If this is our new balloon, the same balloon from which we have removed the mass, the new mass will be m dash. We don't know, we have to calculate that mass. This is acting downward in direction, and the buoyant force is acting on the upward direction, right? Clear? So if the weight still is higher than the buoyant force, it will go down, but the condition is what? That now this m dash is enough that buoyant force can overcome it, and buoyant force will make this balloon to go upward in direction. So this time look at the equation and try to understand that buoyant force is greater than this m dash g, and that will be equals to how much? M dash acceleration of the balloon, right? Now let me be very clear, m dash is the final mass of the balloon, but question is asking how much mass is to be removed, right? So m dash you will calculate and you will subtract it from m. That is the extra mass which you have to remove, right? Means m minus m dash, sorry. So this will be the answer. So let's first calculate m dash. So let's solve this equation. So what is our equation 1? mg minus b equal to ma. So from equation 1, from 1, b will be equals to mg minus ma, correct? Let's substitute this equation in equation 2 at place of b. So it will be mg minus ma minus m dash g equals to m dash a. Sir, what we have to find? The new mass m dash. So this will be equals to mg minus ma equals to m dash a plus m dash g. Let's calculate here. Let's take common m dash, and that will be a plus g over here. And on the left hand side, let's take m common, it will be g minus a, right? Now m dash will be equals to m g minus a whole divided by a plus g. Clear? This is our new mass, but they are asking how much mass is removed. So this is our new mass, not the mass which is removed. So the mass which is removed will be, let me write here, mass removed. That will be equal to the previous mass minus the new mass. So m minus m g minus a whole divided by a plus g. Let's simplify it. Cross multiplying this will give us ma plus mg minus mg and plus ma whole divided by a plus g, or g plus a, whatever you want to call it. Let's cancel out mg with mg, and you left with twice of ma whole divided by a plus g, or g plus a. This is the mass which we have to remove. Let's see if there is any option. What is the option? We got our answer as 2ma upon a plus g. 2ma upon a plus g. Option A is the correct answer for this one. I hope this is clear. Let's see our next question. So our next problem says here, a man of 50 kg is standing in the gravity free space. It's gravity free, there is no gravity. So G or A is 0. So let me just write here, A or G is 0 in this case. And mass of the man is how much? 50 kg, fine. At a height of 10 meter, okay, above the floor. So let's say this is a floor and this is 10 meter above the floor. This person is standing over here, right? Okay, great. He throws a stone of mass. Mass of the stone is how much? It is 0.5 kg downward with a speed of 2 meter per second. So it is going 2 meter per second in the downward direction. When the stone reaches the floor, the distance of the man above the floor will be how much? Okay. So we will use a very basic concept here. Okay. And that is what? Conservation of momentum. Okay. So mass of the man times the velocity of the man will be equals to mass of the stone times the velocity of the stone, right? Very simple concept. Yes. So every action equal and opposite reaction will be. So mass of the man 50, velocity of the man we don't know, mass of the stone 0.5 and velocity of the stone 2 meter per second. So velocity of man will be how much? 1 by 50 from here. I hope this is clear. Now this is the velocity with which the person is thrown in the upward direction because of the reaction. Clear? Now if this is the force, this is the velocity with which the person is going in the upward direction. Let's calculate how much time it takes for the stone to reach to the ground. In that time interval, how much the person will be going up. So the time is equals to, now you can use this equation v equals to u plus at or s equal to ut plus half at square, but the condition here is acceleration is 0, sir, in the problem. So s will be equals to u into t only. Distance is equals to speed into time. So we have to calculate the time. So time is equals to distance upon speed, or let me just make it as distance upon speed. Now what is the distance traveled by the stone? So 10 meters. And what's the speed? 2 meters. So time taken will be 5 seconds. 5 seconds it will go. It will take 5 seconds for the stone to go down, right? In the same time, the time interval being 5 seconds, how much the person is going up? So the velocity of the person is 1 by 50 and the time is 5 seconds. Let's calculate the distance. So distance will be equals to how much? Speed into time. And speed is how much? 1 by 50 and time is how much? 5. So this will make it 5 by 50, which is 1 by 10, or 1 by 10 is 0.1 meters above the building. If it is going 0.1 meter above the building, the question is saying, let's read the question. When the stone reaches the floor, the distance of the man above the floor, not above the building. Be very careful. So above the floor it will be how much? 10 meters is from the this part, and 0.1 it goes on the top. So 10.1 will be our final answer. I hope this is clear to you. Let's see our next problem. So this video I will upload in our playlist. So you can watch the playlist and I'll put the link in the description for the playlist, right? Let's see now our next problem. Okay, I think this is the same problem. Let's see the next one. Okay. Our next problem over here says a body under the action of force. Now what is the force? Force is 6I minus 8J plus 10K. Acquires an acceleration of A is equals to 1 meter per second square. The mass of this body must be how much? Let's find the magnitude of the force, right? Because the acceleration they have given the magnitude and mass is a scalar quantity, right? So magnitude of the force will be root under 36 plus 64 plus 100, right? And 36 plus 64, sir, it's 100. 100 plus 100, 200, right? And 200 is nothing but 10 root 2. If you find the root of 200 is 10 root 2. And acceleration is A. So mass will be simply force upon acceleration by Newton's second law, which is 10 root 2 kg, which is option D. I hope this is clear. Let's see our next problem. Great. Let's see the next problem. The next problem says a block of mass m is placed on a smooth wedge of inclination theta. In case if you are not familiar with the wedge, this is a wedge with an inclination theta. Okay, great. The whole system is accelerated horizontally. So let's accelerate it horizontally in the forward direction with A. I'm just assuming it as A. Okay, so that the block does not slip. Okay, so this is our block and it's not slipping down, right, on the wedge. The force exerted by the wedge on the block must be how much? Okay, so what is very important is try to understand what are the net forces acting on it. Great. So there is a normal reaction N. Let me just write it as N. Weight acting downward mg. Clear? And we know the component of weight in this direction will be mg sine theta. So let me just remove this acceleration for the time being, mg sine theta. And let's write the acceleration over here. Because the acceleration is in the forward direction, a pseudo force will be acting in the horizontally this direction. This is our pseudo force. Be very careful, F. Clear? If this is angle theta, this will be also angle theta, corresponding angles, right? And if that is theta, we know the component of F in this direction will be F cos theta. Clear it is? And here it will be F sin theta. and in this same direction the weight component will be mg cos theta, right, mg cos theta. But what they are asking the force value, the force exerted by the wedge on the block, okay, so that it's not slipping down. So here F cos theta must be equal to mg sin theta. Sir, why you are not taking this next equation like n and all? Because mg sin theta is the force which is responsible for the block to come down. The block is not coming down because mg sin theta is equalized by F cos theta. Otherwise, the normal reaction is getting cancelled with what? With F sin theta and mg cos theta, right? So F cos theta is mg sin theta. So the force will be equals to mg sin theta upon cos theta. Sin theta upon cos theta is how much? Tan theta. So they have not expressed in terms of tan theta. So let's see, this is option D, which is our correct answer. Let's move to the next one. So our next problem here says an object of mass 3 kg. So let's write here m equal to 3 kg is at rest. So initial velocity will be 0 when t was 0. If a force F, which is a function of time, so be very careful, we are given with a function of time here, 4t j cap, is applied on the object, then velocity of the object at t equal to 3 seconds. So at t equal to 3 seconds, we have to find the velocity. Now many students, they can directly divide this force with the mass and find the acceleration and then substitute t. Be very careful, here the force is given as a function and not as a vector, right, or any magnitude value. So what we will do here is we will make use of Newton's second law. What does our Newton's second law says? It says F equals to dp by dt, and putting p we get F equals to m dv by dt, correct? So from this equation we can directly find the velocity. So let's substitute here F as 6t square I cap plus 4t j cap, and taking dt, integration will be equals to m integration of dv. Now m is a constant, so I can substitute here straight away 3, and time, that is going from what? Sir, it is going from 0 to 3 seconds, and velocity when t was 0, its initial velocity was 0, and final velocity, let's take it as v, which we have to find, right? So let's integrate it. 6t square integration is t cube by 3, correct? 0 to 3 I cap plus 4 outside, integration of t square by 2, 0 to 3 j cap, that will be equals to 3, and integration of dv will give us v only, correct? So this will give us how much? Taking this 3 outside, it will be 2 t cube from 0 to 3, and I cap, be very careful, components are very important, I cap plus 4 divided by 2, which is 2 t square from 0 to 3 j cap, that is equal to 3v, and let's substitute the value. It will be 3 3s are 9 3s are 27 minus 0 I cap, and here we left with 2 into 3 3s are 9 minus 0 j cap, and that will be equals to 3v, right? 27 2s are 54 I cap plus 18 j cap whole divided by 3. I am taking this 3 from the left hand side, right hand side to left hand side. So 54 upon 3, that will be 18 I cap and 6 j cap, that's our velocity. Let's see what's our answer. So 18 I cap plus 6 j cap, that's option B. I hope this is clear. Let's see our next problem. So our next problem over here says a player takes 0.1 second in catching a ball. Okay, that's a reaction time. So time t is equals to 0.1 second of ball of mass 150 grams. Let me convert it here only so that we don't forget it later on. So kg, moving with the velocity, so u is equals to 20 meter per second. What is the force imparted by the ball on the hands of the player? Very simple question, okay? V will be equals to, this is also asked in 2001, so be very careful, such easy problems sometimes they ask, okay? So V is equals to 0. So we know that F equals to dp by dt, or since here it is not in terms of functions, so we can write here final momentum minus initial momentum upon time. So this is mv minus mu upon t, right? So m is how much? Let's take common, 150 into 10 to the power minus 3. Final velocity is 0. So u will be how much? Minus 20, and time is 0.1, right? Let's simplify it further. So it will be how much? minus I am taking, because they are saying imparted on the hand, so this will be negative here, and 15 twos are 30, so this will be 3000, so 10 to the power minus 3 upon 0.1, that would be how much? Minus 30 Newton. Is there any option? Yeah, option C, magnitude they have given, so magnitude must be 30 Newton. That is our correct answer, right?